Jai Shri Krishna friends. Last time we can discuss about the tautomerism and some basic concepts of tautomers, like which compound shows the tautomerism, what is the condition, what is the exceptional case, whatever. In this lecture or last lecture of tautomerism, we can show the percentage of enol content and stability of enol. It is very important from the point of view of competitive exams like NEET and JEE. It is very important from the point of view of MCQs. Percentage of enol content and stability of enols. Generally, keto form is a more stable in 90% cases from enol. In general, keto form is a more stable than enol form in 90% cases. Means that in about 10% some exceptions are there, which you can study in this lecture. Clear? Generally we can remember that generally keto form is a more stable. If any compound have keto form and enol form, here we can particularly discuss about the keto-enol tautomerism. Then in 90% cases, keto form is a more stable than enol form. We can have an example like that. We can have an acetone, CH3 C double bond O CH3 acetone, which is a keto form. We can convert it in a enol form with the help of XYZ, Z, Y, X, 1, 2, 3. You can transfer hydrogen from position number 1 to position number 3, and you can transform the double bond from position number 2, 3 to 1, 2, and the enol form is like that. If we can discuss the amount of the forms, it is near about more than 99% in a dynamic mixture, equilibrium mixture, and the enol form is near about less than 1%. Means that these both form are exist in a dynamic equilibrium, but the more amount of the content is keto form due to the higher stability of ketone. Due to the higher stability of keto form. Someone can ask why generally keto form is a more stable than enol form. Then the reason is that because in keto form the carbonyl groups are there, C double bond O, whatever R, A, R, but we can have generally particular bond C double bond O in keto form. In keto form and in enol form, generally we can have carbon-carbon double bond, which you can show here. We can say that if we can study the bond energies or bond enthalpies of keto form and enol form, then C double bond O bond is a more strong than C double bond C. Therefore, we can say that bond energy or bond enthalpy of this form is of this bond is a more. Therefore, we can have more amount of keto form. A bond એટલો બધો strong है कि એને બ્રેક કરવા માટે વધારે અમાઉન્ટમાં એનર્જીની જરૂર પડશે અથવા તો ફેક્ટરને બહુ હાઈ રાખવા પડશે, જેથી કરીને કહી શકીએ કે મોસ્ટ ફેવરેબલ કન્ડિશન કઈ હશે તો કે કીટો, બીકોઝ ધ બોન્ડ ઇઝ મોર સ્ટેબલ. વી નોઝ ધેટ સ્ટેબલ કમ્પાઉન્ડ ઇઝ અવેલેબલ ઇન અ મોર અમાઉન્ટ in dynamic equilibrium in keto-enol tautomerism. Therefore, keto form is a more stable than enol form because in 90% cases, not in all cases, keto form is a more stable than enol due to the bond energy or bond enthalpy of a keto form is a more than enol form. Means carbonyl is more stable or more stable than carbon-carbon double bond. Suppose if we can have a compound like that, H C double bond O CH2 C double bond O H, we can design at XYZ here Z Y X or also Z Y X. This is a keto form. This is a keto form. If you can draw the enol form of this compound, then there are two possibilities. First possibility is that we can transfer hydrogen from 1 to 3 and we can transfer double bond from 2 3 to 1 2, then the compound is like that. Means that અત્યારે અહીંયા બે હાઇડ્રોજન આપણને જોવા મળે, we can source the two hydrogen here. From this only one hydrogen we can shift to the Z atom. એમાંથી ફક્ત આપણે અત્યારે એક જ હાઇડ્રોજનને શિફ્ટ કરેલો છે. Then we can source the enol form like that. But if we can check the experimental data, then we can say that it is only in 60% then enol form. Enol form is a more amount here, 84%. What is this? This is an exception. This is a exception. Why this is exception? We can study in this lecture. Generally, we can say that keto form is a more stable than enol form, but in not all cases like that. Here keto form is a less amount than enol. Here enol is a more stable or present in a more amount. અત્યારે આપણી આગળ વધારે અમાઉન્ટમાં પ્રેઝન્ટ હશે, જ્યારે કીટો લેસ અમાઉન્ટમાં પ્રેઝન્ટ હશે. શા માટે આપણે સમજવાનો પ્રયત્ન કરીએ, બટ એની પહેલાં આપણે એક બીજી પોસિબિલિટી વિચારીએ. એક પોસિબિલિટી તો આપણે આ વિચારી કે હાઇડ્રોજન આ સાઈડ શિફ્ટ થાય અથવા તો હાઇડ્રોજન આ સાઈડ શિફ્ટ થાય, તો ફોર્મ્યુલા સેમ જ રહે, बिकॉज स्ट्रक्चर सिमेट्रिकल है. તમે હાઇડ્રોજનને આ સાઈડ લઈ આવો કે હાઇડ્રોજનને આ સાઈડ લઈ આવો, કમ્પાઉન્ડ આ જ ટાઈપનો ફોર્મ થાય. ઇફ યુ કેન ગીવ ધ IUPAC then the name is same. તો કોઈ મતલબ નથી કે હાઇડ્રોજનને તમે આ સાઈડ લઈ જાઓ કે આ સાઈડ લઈ જાઓ, બેમાં આ જ કમ્પાઉન્ડ ફોર્મ થશે. બટ ધ સેકન્ડ પોસિબિલિટી ઇઝ ધેટ ઇફ યુ કેન રિમૂવ બોથ હાઇડ્રોજન ફ્રોમ ધ X and we can give one hydrogen to this oxygen atom and one hydrogen to this oxygen atom, then the compound form is like that. હવે શું થશે તો કે એક હાઇડ્રોજનને આપણે 1 2 3 આ બાજુ લઈ ગયા એટલે OH થઈ ગયું. હવે આ ડબલ બોન્ડ તો અહીંયા શિફ્ટ થઈ ગયો એટલે એ આ સાઈડ આવી ગયો. નેક્સ્ટ વન ઇઝ ધેટ we can remove hydrogen, we can remove one hydrogen here and one hydrogen here. Therefore OH and this double bond is shifted to there. Therefore the second possibility of the enol form is like that. But from these two enol forms, stability of first is more than 2 due to the carbon double bond is a very unstable double bond as compared to enol form. Yes, this type of double bonds is known as cumulative double bonds. Generally cumulative double bonds are less stable. Therefore we can say that if question is like that, the compound આપણને compound draw કરીને આપ્યો હોય, the compound gives the enol forms A B C D whatever, A આપ્યો હોય, B આપ્યો હોય, C D આપ્યો હોય, અને question આવો કરવામાં આવ્યો. Question is like that, from this which enol form is a more stable, therefore we can tick this form because it is a more stable than this, because it can have a cumulative double bond which is a very less stable. And second reason is that if we can check the conditions in first and second compound, therefore we can say that first compound have hydrogen bonding. First compound have intramolecular hydrogen bonding. आज कंपाउंड ने આપણે અહીંયા વાઇડલી ડ્રો કરેલો છે CCHHOH CH C double bond OH. Here the possibility of hydrogen bonding, and we knows that if the hydrogen bonding is there, then the stability is increases. Therefore this compound is more stable. And general concept is that yes, this is the possibility of hydrogen bonding. Here no possibility of hydrogen bonding because this is unstable these unstable bonds break the compound. Next, general concept is that if in any compound conjugation are there, then the stability is more. Conjugation is more, stability is more. Conjugation is more, stability is more. What is conjugation? We can explain in last lecture. Conjugation means double sigma double or lone pair single double single lone pair. This type of arrangement is known as conjugation. If conjugation is there in the compound, then the stability is more. If we can check here, we can have a conjugation. Lone pair single double, it is a conjugation. Therefore it is more stable. If you can check in this compound, then the condition is like that. Lone pair single double, conjugation is break. If two double bonds are present in one carbon, therefore conjugation is break, because conjugation double single double type નું હોય. અત્યારે તો આપણી આગળ આવું હોય કે double તો conjugation break થયું, stability decrease થાય. Remember this always, friends. If electron charge is delocalized, then the stability is increased. If any species or compound have a charge, electron charge, if electron is delocalized in compounds, then the stability is increases. Means that if any compound, suppose A, have an electron or charge, and the electron or charge is not shifted to the other atoms, then this compound is unstable. And suppose A B and C, like that compound, here a charge, and this charge is shifted or delocalized to this position or this position. Therefore we can say that if electron is delocalized, if electron is moves, then stability increases. If any atom have a charge and this charge is not delocalized, not move, then for the stability is decreases. This concept is very useful to detect the amount of Enol content. Also we can say that if electron disperse means moves through the compound, then the stability increases. And very important factor for the more stability is also hydrogen bonding. So we can shows the examples and some factors to decide the stability of Enol content. Now from this lesson we can say that Enol stability depends on these four factors. Enol stability depends on these four factors. First one is aromaticity or aromatic compound, second one is hydrogen bonding, third one is conjugation, and fourth one is solvent effect. There are four factors which can affect the stability of Enol. First one is aromaticity or aromatic compound, second one is hydrogen bonding, third one is conjugation, and fourth one is solvent effect. First we can consider these two effects. If any compound have aromatic character and hydrogen bonding, generally in this case keto form is less stable than enol form. Generally if any compound which is aromatic or which can have hydrogen bonding, then we can say that keto form is a less stable or less in amount than enol form. We can say that in above example, generally keto form is a more stable than enol form, but we can check this characteristic. If the compound have aromatic character or hydrogen bonding, then the condition is reverse, then enol form is a more stable than keto form, remember that. And the second two factors are conjugation and solvent effect. Suppose these conditions are, we can study with the help of examples. Suppose question is that CH3 C double bond O, CH2 C double bond O, CH3 keto form. Here a blank, dynamic arrow, here a blank is a more stable enol form. Question આવો કરવામાં આવ્યો કે આ keto form નું more stable or more stable enol content enol form કયું હશે? Yes, there are four options. It is the solution. It is the solution, but the options are like that. CH2 double bond COH, CH2 C double bond O, CH3. Option B, CH2 double bond COH, CH2 COH double bond CH2 double bond CH2, CH3 COH double bond CH, C double bond O, CH3, CH3 COH double bond C double bond C OH CH3. These four are the enol contents of this compound, because here three possibilities X, Y, Z, X, Y, Z, X. અહીંયાથી પણ હાઇડ્રોજન શિફ્ટ થઈ શકે તો આપણને આ કન્ટેન્ટ મળશે. અહીંયાથી પણ હાઇડ્રોજન શિફ્ટ થઈ શકે તો આપણને આ કન્ટેન્ટ મળશે. જો આ બે સાઈડથી આપણે હાઇડ્રોજનને શિફ્ટ કરાવીએ તો આપણને કન્ટેન્ટ આ મળશે, અને જો આપણે બે હાઇડ્રોજનને અહીંયાથી શિફ્ટ કરાવીએ તો કન્ટેન્ટ આપણને આ મળશે. There are four possibilities to form an enol content of this compound. We can explain. If we can remove these hydrogen, if we can shift these hydrogen, we can form this content. If we can remove these two hydrogens, we can contain this form. If we can remove these hydrogen, we can form the compound like that. અત્યારે આપણે એવું કર્યું કે અત્યારે કોઈ પણ એક જ સાઈડ હાઇડ્રોજનને શિફ્ટ કરાવ્યો, બે હાઇડ્રોજનને શિફ્ટ કરાવ્યા નથી. Suppose if you can shift two hydrogens simultaneously, therefore we can get this form. Now the question is that from this which is more stable, we can check hydrogen bonding and conjugation. In first compound there is 100% possibility of hydrogen bonding. There is 100% possibility of hydrogen bonding, but it cannot have extended conjugation because double single single conjugation break, or here lone pair sigma sigma break, conjugation નથી આની અંદર. Hydrogen bonding છે, conjugation નથી, extended conjugation. Next one is that there is also a possibility of hydrogen bonding. There is also a possibility of hydrogen bonding, but this compound also does not contain a conjugation because lone pair સિંગલ સિંગલ. જો એ ડબલ બોન્ડ હોત તો કોન્જ્યુગેશન થાત, મતલબ કે આપણે કોન્જ્યુગેશન નથી, આમાં પણ કોન્જ્યુગેશન નથી. નેક્સ્ટ વન CH3COH double bond CH C double bond O CH3. There is a possibility of hydrogen bonding and there is a possibility of conjugation because lone pair, sigma, double, single, double. There is an extended conjugation. This compound have both condition, hydrogen bonding and conjugation. Lone pair, single, double. And last one, there is hydrogen bonding. Possibility of formation of hydrogen bonding, but it cannot have a conjugation because lone pair sigma double પછી single આવતું હોત તો conjugation હોત. The picture is clear. It is stabilized by hydrogen bonding, but it is stabilized by two factor, conjugation and hydrogen bonding. Obviously this form is present in a more amount, therefore these three contains, and this cannot have a conjugation. Generally in this compound keto form is a 24% and this enol form is a 76%. Therefore answer is C. Therefore answer is option C. Suppose the question is like that, arrange the following in increasing order of their enol content. Yes, if we does not know the concept, therefore these four options are same. જો આપણને કોન્સેપ્ટ ખબર ન હોય તો આપણને ચારે ચાર ઓપ્શન સેમ જ લાગે, આપણે કોઈ પણ ઓપ્શનને ટિક કરી દઈએ, but we can know the concept, we can very easily detect the answer. Arrange the following in increasing order of their enol content. First one is A, CH3 C double bond O CH3 acetone. Second one is B, CH2 double bond C H C double bond O. And third one is benzene ring C double bond O CH3. We can make its enol content, enol form. This is a keto form, keto and keto. First of all we can make its enol form. The enol form of this compound is that, yes, you can practice it, 1 2 3 XYZ. The enol content of compound B is this because X, Y, Z. This hydrogen is shifted here and double bond is shifted here to here. And third one is like that because X, Y, Z. Here we cannot consider X because 4 valencies of carbon is already satisfied with carbon. Next, now how we can detect that this 3 from which enol is a more stable? If you can check here, this is no conjugation because lone pair sigma double bracket. Extended conjugation હોય તો stability increase થાય. Yes, it is a conjugated compound because double single double or lone pair single double. Therefore you can say that double single double or lone pair single double. Therefore you can say that this compound has a conjugation, but this conjugation is not very strong. Therefore in this example keto form is a more stable than enol form. It is also one exception. Conjugation એની સ્ટેબિલિટી ઇન્ક્રીઝ કરે પણ એટલી બધી ઇન્ક્રીઝ નહીં કરી શકે ઇનોલ કન્ટેન્ટની સ્ટેબિલિટી કે કીટો કરતાં વધારે સ્ટેબલ થાય. યસ, કોન્જ્યુગેશન છે પણ વીક કોન્જ્યુગેશન, ડબલ સિંગલ ડબલ વધારે એક્સટેન્ડેડ હોય તો સ્ટેબિલિટી ઇન્ક્રીઝ થાય. નેક્સ્ટ, if you can check this compound, it can have also a conjugation because double single means that conjugation is very strong as compared to this compound. Conjugation is very strong as compared to this compound. And the another effect which we can know or shows in this compound is, if we can check this ring, this is a phenyl ring. This is a phenyl ring, and remember that friends, phenyl ring is an electron withdrawing group. Phenyl ring electron ને attract કરવાનો પ્રયત્ન કરશે. Phenyl ring is an electron withdrawing group, EWG, electron withdrawing group. And if any compound contain an electron withdrawing group in a conjugation, then stability is increases or conjugation is increases. If double bond contain an electron withdrawing group or single bond contain, yes, single bond contain or the compound contain an electron withdrawing group, their conjugation is increases, and if conjugation is increases, then stability is increases. We knows that. Suppose if we can have an electron donating group, then conjugation is decreases and stability of enol content is decreases. From this we can say that the order of enol content is like that: A, B, C. C compound ની અંદર more conjugation હોવાથી more stable થશે, એનું content વધારે મળશે, જે stable એનું content વધારે મળે, then B and then C. Yes, આ એક યાદ રાખજો. This is remember, electron withdrawing group conjugation increase करे, electron donating group conjugation decrease करे. જો conjugation increase થાય તો stability increase થાય, જો conjugation decrease થાય તો stability decrease થાય. Next we can take some examples in which the compound in which enol form is a more stable or more amount than keto form or keto content. We can take some examples of this compound in which enol content is a more than keto content. First one is that 6-member ring, double bond and double bond O. This is a keto form. If you can convert into the enol form, then Z, Y, X compound is like that, because hydrogen is, yes, here 2 hydrogens, one hydrogen is transformed 1 to 3 and double bond is transformed 2 3 to 1 2. Therefore we can have a compound like that which is a enol content and known as phenol. Yes, one hydrogen is here. If you can check the conditions, then this compound is aromatic, because 1 2 3 means 6 pi electron, cyclic compound, planar compound, conjugation is there, double single, and this, therefore this compound becomes a aromatic, and this also possibility of hydrogen bonding. And if 2 factors are there, therefore no problem, enol content is a more stable than keto content. જો આ બે ફેક્ટર એક સાથે પ્રેઝન્ટ હોય તો વિચારવાનું જ નથી થતું. enol content એમ generally keto content કરતા more stable જ હોય. Nearly this is 100% and this is 0%, because aromatic compound is a most stable compound, Second example is like that: 6-member ring, double bond O, double bond O, double bond O. There are so many enol forms we can draw, but we can draw the most stable enol forms of that. Here X, Y, Z, Z, Y, X, Z, Y, X. We can remove, we can transfer hydrogen from here to here, hydrogen from here to here, and hydrogen from here to here. We can have the compound like that, which is also aromatic, because cyclic, all are in a sp2 hybridization, planar, conjugated, because double single, and therefore you can say that the compound is a aromatic. There is no possibility to form a hydrogen bond, but due to the aromaticity or aromatic character, this compound is the most stable and it present in 100%. And this compound is nearly 0%. Suppose if we can have a compound like that, 6-member cyclic ring, double bond O. If we can convert XYZ, convert into enol form, most stable enol form, therefore it is like that. અહીંયાથી હાઇડ્રોજન અહીંયા ટ્રાન્સફર થયો, અહીંયાથી હાઇડ્રોજન અહીંયા ટ્રાન્સફર થયો, બે જગ્યાએ ડબલ બોન્ડ શિફ્ટ થયા, આ ડબલ બોન્ડ અહીંયા શિફ્ટ થયો, આ ડબલ બોન્ડ અહીંયા શિફ્ટ થયો. enol form is like that. Here also enol form is a 100% and their keto form is a 0%, but the reason is different. Here, yes, possibility of hydrogen bonding is there. These oxygen form hydrogen bond with this hydrogen and these oxygen form hydrogen bond with this hydrogen, but there is no possibility to aromatic, because yes, cyclic છે compound, the compound is a cyclic but not planar. The hybridization of this and this carbon is a sp3 which is non-planar, therefore you can say that the compound is a non-aromatic. But compound is a non-aromatic, but the reason is that why this is in 100%, because first reason is that it can have a hydrogen bonding, and second reason is that if you can check the dipole repulsion of this compound, oxygen double bond થી bonded है, electron ने आ side રિપલ કરતો ટૂંકમાં વિડ્રો કરતો હશે, ડબલ બોન્ડ O એ પણ ઇલેક્ટ્રોનને આ સાઈડ એટ્રેક્ટ કરતો હશે. ડ્યુ ટુ ધ ડાયપોલ રિપલ્શન અકર્સ એન્ડ નોટ સ્ટેબલ, therefore enol content is a more stable. આ ખુદ the compound itself is not stable. આ સ્ટેબલ નથી એટલે આ મોર સ્ટેબલ है, बिकॉज आ डायपोल जो रिपल्सन है ये अनस्टेबल बनावे, डायपोल जो रिपल्सन है ये अनस्टेबल बनावे जेथी करीने कंपाउंड मोर स्टेबल है. सो सम स्पेशल एग्जांपल लाइक दैट. नाउ वी कैन थिंक अबाउट वन क्वेश्चन, एंड द क्वेश्चन इज लाइक दैट, इफ वी कैन हैव कंपाउंड लाइक दैट, benzene ring C double bond O, benzene ring C double bond O, CH2 C double bond O, CH3. This is the dynamic equilibrium, and we can have some possibilities of the enol form of this compound because it is a keto form. From this, which enol form is a more stable, less stable, we can give the order. मीन्स दैट आ कंपाउंडना इनोल फॉर्म આપણે પહેલા ચેક કરશું પોસિબિલિટીમાં 3-4, પછી ઇનોલ ફોર્મમાંથી કયું ઇનોલ ફોર્મ વધારે સ્ટેબલ છે આપણે ડિસાઇડ કરશું વિથ ધ હેલ્પ ઓફ સમ ફેક્ટર્સ. ફર્સ્ટ પોસિબિલિટી ઇઝ ધેટ x y and z O double bond O. If we can transfer this hydrogen to this oxygen, then the compound is like that. ડબલ બોન્ડ ઇઝ શિફ્ટેડ ટુ હિયર ટુ હિયર. જો આપણે આ હાઇડ્રોજનને અહીંયા શિફ્ટ કરીએ તો 1-3 શિફ્ટના કારણે આપણને આવું ઇનોલ કન્ટેન્ટ મળે. યસ, પહેલાં આપણે પોસિબિલિટી વિચાર લઈએ. સેકન્ડ એક્ઝામ્પલ ઇઝ લાઇક ધેટ, હવે અહીંયાથી આપણે હાઇડ્રોજનને અહીંયા શિફ્ટ કર્યો છે. પહેલાં ફર્સ્ટ કમ્પાઉન્ડમાં શું કર્યું તો કે હાઇડ્રોજનને અહીંયા શિફ્ટ કરાવ્યો 1-3 શિફ્ટ. હવે આ જ હાઇડ્રોજનને આપણે સેકન્ડ કેસની અંદર અહીંયા શિફ્ટ કરાવીએ તો ડબલ બોન્ડ અહીંયા આવશે ને OH અહીંયા બનશે. નેક્સ્ટ વન, here also x z y x. In next compound we can shift this hydrogen here and we can get double bond here. આ સાઈડ આપણે કોઈ પણ ચેન્જીસ કર્યો નથી. ફર્સ્ટ ટાઈમ we can transfer hydrogen to here, in second compound hydrogen to here, and third compound this hydrogen to here. And fourth possibility is like that, fourth possibility is like that, these hydrogen transform here and these hydrogen transfer here simultaneously. બે હાઇડ્રોજન આપણે શિફ્ટ કરાવ્યા, આ હાઇડ્રોજનને આપણે આ સાઈડ શિફ્ટ કરાવ્યો અને આ હાઇડ્રોજનને આપણે આ સાઈડ શિફ્ટ કરાવ્યો, એટલે અહીંયા પણ ડબલ બોન્ડ, અહીંયા પણ ડબલ બોન્ડ ને બે સાઈડ OH. Now we can check the stability of this enol contents. First we can take conjugation and hydrogen bonding. This compound have a conjugation and hydrogen bonding because single double and hydrogen bonding, and it is also a strong conjugation, pi sigma pi sigma pi sigma, double single extended conjugation. Next, in this compound also a possibility of hydrogen bonding and conjugation because pi sigma double single double. Next, there is no possibility of conjugation here. બેન્ઝીનની રિંગમાં તો કોન્જ્યુગેશન બધામાં છે જ, પણ એ બધામાં કોમન છે. તો અત્યારે જો ડબલ સિંગલ ડબલ આમાં પણ ડબલ સિંગલ આની અંદર જો ડબલ બેન્ઝીનની રિંગની હવે આપણે વાત નહીં કરીએ બિકોઝ એ તો બધાની અંદર કોમન છે. ડબલ સિંગલ conjugation is break. Double single conjugation is break, but the possibility of hydrogen bonding is there. And in last case, single double or lone pair single double. Therefore we can say that this compound have a conjugation and hydrogen bonding also. Now we decide if we can think about hydrogen bonding. Hydrogen bonding is present in all compound, therefore you can decide the stability with the help of conjugation. But in fourth one compound there is a 2 carbon double bond. There is a 2 carbon double bond which is stable and it gives the stability. Next, from these 4, which enol form is a more stable, we can decide. ફર્સ્ટ અહીંયા જુઓ, આપણે આ હાઇડ્રોજનને શિફ્ટ કરાવ્યો તો આ સાઈડ, આ હાઇડ્રોજનને આપણે શિફ્ટ કરાવ્યો તો આ સાઈડ. Then the question is that phenyl is an electron withdrawing group. Phenyl is an electron withdrawing group and methyl CH3 is an electron donating group. Phenyl is an electron withdrawing group and methyl is an electron donating group. Therefore electron અહીંયાથી આપણે હાઇડ્રોજન અહીંયાથી આપણે અહીંયા શિફ્ટ કરાયો. હાઇડ્રોજન આ સાઈડથી આ સાઈડ શિફ્ટ થયો, પણ હાઇડ્રોજનને ખરેખર શિફ્ટ થવાનું આ સાઈડ હતું તો એ મોર સ્ટેબલ થાય. ક્લિયર? નેક્સ્ટ, in this compound electron withdrawing group, electron donating group. Yes, here hydrogen is transformed to this side, therefore it is favor the conjugation, and in this compound there is no conjugation, therefore it is a least stable. There is no conjugation, therefore it is the least stable. હવે આ થર્ડ માંથી આપણે ડિસાઇડ કરીએ તો મોસ્ટ સ્ટેબલ કયો થાય તો કે સેકન્ડ વન 89% પ્રેઝન્ટ હશે, બીકોઝ ઇલેક્ટ્રોન વિથડ્રોઈંગ ગ્રુપ એન્ડ ઇલેક્ટ્રોન ડોનેટિંગ ગ્રુપ હાઇડ્રોજનની કન્ડિશનને ફૂલફિલ કરે છે. Therefore it is a most stable. And now if you can think from these two compounds, first and fourth compound, therefore fourth one is a less stable as compared to first one. Then the order is that enol content we can obtain is like that. Clear? Next one example is like that. Arrange in increasing order of enol content. A is CH3 C double bond O CH3, B is phenyl ring or benzene ring C double bond O CH2 CH3, C is CH3 C double bond O CH2 C double bond O CH3, and D is 6-membered ring double bond and C double bond O. We can arrange in the increasing order of enol content. First we can draw the enol contents of this 4 compound. The enol content of A is like that because Z, Y, X. We can transfer hydrogen from X to Z and double bond from XY to YZ. We can get the compound like that. From this ZYX, hydrogen transfer from X to Z and double bond is YZ to XY. Then the compound is like that. In C, it is generally known as 1,3-diketones. It is generally known as 1,3-diketones. In C, ZYX. We can transfer one hydrogen from here to here and we can draw the enol form of that. And in last XYZ, 2 hydrogens are there. We can transfer one hydrogen to here and double bond is shifted from YZ to XY. Then it is like that. Now we can check the conditions. In first condition there is no conjugation, there is no hydrogen bond. હવે હાઇડ્રોજન બોન્ડ બનવાની પોસિબિલિટી નથી અને કોન્જ્યુગેશન પણ નથી. સેકન્ડ ની અંદર જો આપણે ચેક કરીએ તો લોન પેર, સિગ્મા, ડબલ, સિંગલ means conjugation is there. There is no possibility of hydrogen bonding. If we can check here, it is a possibility of hydrogen bonding. If you can check here, therefore we can say that this is the possibility of hydrogen bonding and also a conjugation because lone pair, single, double, conjugation પણ है, हाइड्रोजन बॉन्डिंग પણ અત્યારે આપણને અહીંયા જોવા મળે છે. નેક્સ્ટ કમ્પાઉન્ડ બનશે આ સાયક્લિક sp2 planar and 6 electrons are delocalized, therefore the compound is aromatic. Then the compound is aromatic and it is very most stable compound, therefore you can say that it is a most stable. Therefore this enol content is present in a more amount. This can have a 2 condition, conjugation and hydrogen bonding. So we can say that from then after C it can have only 1 condition, conjugation. Therefore B it can have no any condition, therefore A. Therefore enol content of D is more than C, then B and then A. Remember that generally hydrogen bonding shows in 1,3-diketones. Generally hydrogen bonding is shows in 1,3-diketones. Clear? Now we can discuss about the last factor. The factor is that effect of solvent. we can discuss about the 4 factors: aromatic, hydrogen bonding, conjugation, and solvent effect. Now we can discuss about the solvent effect. First point is that we can consider first this effect. બધી જ ઇફેક્ટ હોય તો ફર્સ્ટ આપણે આને કન્સિડર કરવાની થાય. We can consider first this effect, solvent effect. There are 2 types of solvent are there: polar protic solvent and polar aprotic solvent. Polar protic solvent and polar aprotic solvent. This is the examples of polar protic solvent: H2O, CH3CH2OH means ethanol, acetic acid CH3COOH, and this is the examples of polar aprotic solvent: acetone means CH3 double bond OCH3, benzene means C6H6, and hexane. Now if you can have a polar protic solvent, yes, what is the meaning of polar protic? Means this type of compound is a polar and protic. Protic means it can give the proton. This type of compound is a polar and gives the proton, therefore it is known as polar protic. And this type of compound is a polar but not a protic, means it cannot give the proton. This is the difference: polar and protic, polar and aprotic. This is a polar and gives the proton, this is a polar but does not gives the proton. Generally polar protic solvent percentage of enol content ने decrease करसे. Generally polar protic solvent percentage of enol content decreases like that. Suppose if you can take the example of CH3 C double bond O, CH2 C double bond O, CH3 in the presence of water, which is a polar protic solvent. If we can get the enol form CH3 COH double bond CH C double bond O, CH3, you know that X Y Z અહીંયાથી હાઇડ્રોજનને આપણે એક શિફ્ટ કર્યો, ડબલ બોન્ડ અહીંયાથી અહીંયા શિફ્ટ થઈ ગયો. ક્લિયર? Therefore you can get enol content is 20% and keto percent is 80%. But if this tautomerism we can discuss without solvent, मतलब कि कोई solvent જ न રાખીએ, or gaseous phase or acetone. Acetone is a polar aprotic. Therefore this enol content is a 76% and keto content is a 24%. Yes, therefore you can say that presence of polar protic solvent decreases the content of enol, clear? And polar aprotic solvent percentage of enol content increases. If the presence of polar aprotic solvent, therefore the enol content is increases. We can have some order to enol content order in different solvents. We can take a different solvent and we can decide the enol content, and the order is like that: hexane gives higher enol content, then benzene, then acetone, then methanol or ethanol, in general alcohol, and then H2O. Clear? This order is very important for the point of view of MCQs. Enol content order in different solvent is like that: higher enol content hexane, therefore benzene, therefore acetone, therefore alcohol, methanol or ethanol, and therefore H2O. So friends, we can complete here a tautomerism. We can try best to explain the tautomers or tautomerisms or conditions or what is the stability factors or important special cases. In next lectures we can discuss about the stereoisomers or stereoisomerisms. So